Thank you for joining us today. And in this video, we are going to talk about change rule, right? So we talked about change rule and we want to look at this question where we have y is equal to f of gen of x. And we are saying that based on the change rule, when we differentiate, this is what we are going to get, right? So now we are assuming that y is equal to what is here, right? The first thing that we need to do is we need to make sure that we rewrite this equation as, or this function as, x squared plus 7x plus 2 to the power 1 over 2. So when I write this, then we see that y is equal to what is here, which is here, and then we are saying that it's the same as f of gen of x. So what I'm going to do is I'm going to base on this function to choose my f of x, gen of x. But the strategy here is always choose your gen of x first. When I choose my gen of x, it will help me to know my f of x, right? So my gen of x is always the one in the parentheses here. So it means that I'm going to have x squared plus 7x plus 2. That would be my gen of x, right? Now, when I choose this one to be gen of x, now you will see that now the one in the parentheses here is like gen of x. So what are we going to do? We can say that this equation here is the same as gen of x to the power 1 over 2, right? Because we know that the one in the parentheses here is what we are saying that is equal to gen of x. So in place of x squared plus 7x plus 2, I can put gen of x there, having my 1 over 2 there. So because of that, then our f of x now will be equal to what is here. But I'm going to do something here. Why? Because gen of x is here, so we cannot put gen of x here. When I put gen of x here, it will be like me having something like f of gen of x, and when I apply the change rule, this is what I'm going to have. So what I'm going to do is I will let my gen of x to be equal to u, right? This gen of x to be equal to u, so that now I can change the gen of x here to u, which I will write it for what? F of x. So it means that this is going to be u1 over 2. So I have u to the power 1 over 2, right? And u here is equal to x squared plus 7x plus 2. So this is what the functions that I have now. Now I can find f prime. So because this function is u, when you see f prime, based on what we learn, you see that if you see f prime here is like f of d of f of x divided by du based on the change rule. So that is what is f prime here represent. So we are going to differentiate this, and based on the power rule, we are going to have 1 over 2 u, then 1 over 2, right? So the power rule says that drop the 1 over 2 down, maintain the whole function, then you subtract 1. So this will be 1 over 2 u to the power minus 1 over 2. Now this is equal to, now after we are done with the derivative, now we need to know that, let's assume that the function here is in terms of x. So this one too should be in terms of x. Now what is u? We need to replace u. U is here, and we are saying that u is the same as x squared plus 7x plus 2. So we are going to have 1 over 2, open bracket, x squared plus 7x plus 2, negative 1 over 2. So this is what you are going to get for the f of x, right? F prime of x. Then what is gen prime of x? Now we have gen of x to be this. So gen prime of x, x squared, when I differentiate, I'll have 2x. When I differentiate 7x, I'm going to have 7. And when I differentiate 2, I'm going to have what? 0. So now, based on the chain rule here, then we just need to multiply f prime and gen prime, right? So our f prime is equal to what is here, and then our gen prime 2 is equal to what is here, right? But don't forget, this s here is like gen of x. So mostly, even some people will write this one as, let's say, x to the power 1 over 2, which is also right? So when you write x to the power 1 over 2, then don't forget this x here is like the gen of x, so that you can plug it in. But it's good for you to use the u so that you will know the type of variables that you are going to what use. So now what I'm going to do is I'm going to multiply f prime to what g prime. So this times that. So I'm going to have 1 over 2 x squared plus 7x plus 2 negative 1 over 2 times 2x plus 7. Now I saw some of you did something like this. This will cancel this. No, we cannot cancel this and this because of the plus 7 here. If there was no plus 7 and this one was like this, then I can cancel this and this. But because of the plus 7, you cannot cancel this and this. Right. So what you can do, if you want to do further simplification, then you can multiply this one by the whole function in the bracket here. So we are going to have 1 over 2, 2x plus 7, then x squared plus 7x plus 2 minus half. You can even leave your answer in this form. It's okay to leave it in this form, right? So that is the idea. Now let us pick another one which is similar, but what we are going to do is different function. So the same idea here. Let's choose gen of x first. So gen of x is always the one in the parentheses. So I'm going to have ex plus x, and I'm going to set this one to u, right? So that when I set this one to u, now this function here, since we are saying that the one in the parentheses is the same as gen of x, I'm going to have it of the form gen of x all to the power what 10. But I'm setting this one to u so that I can write my f of x, right? So now gen of x is equal to u. So in place of the gen of x here, I'll put u there so that I'll have this one to be u to the power 10. Is that right? Good. So now that I have my f of x, I have my gen of x, I can take the derivative. What will be f prime? Based on the power rule, 10 drops down, then I maintain u to the power 10, then I subtract 1, right? So this is going to be 10 u to the power what? 9. Now you ask yourself, what is u? U here is equal to e to the power x plus x. So I'm going to have something like 10 e to the power x plus x all to the power 9. So now what is gen prime? Gen prime, we have gen of x to be this. Now exponential function, I think we learn how to, I'm going to do individual, I'm going to do video on how to differentiate individual functions. So when you want to differentiate e, this is what you need to do. Let's assume that I want to differentiate ex. This is going to be equal to, first I'll maintain the function times, then I'll take the derivative of the top. So when I take derivative of the top, which is x, I'm going to have 1. So when I differentiate e to the power x, I have e to the power x plus, when I differentiate this x here, I'm going to have 1, right? So now I just need to multiply this function and this function to obtain dy over dx. So 10 e to the power x plus x 9 times, now this is two functions, so I need to put it into what? Parentheses. Some of you will just write like something like times e to the power x plus 1. So when you do it that way, you will see that when you are doing the multiplication, you might just multiply this one by this to get something like 10 e to the power x ex plus x to the power 9 plus 1, which is a big mistake. You cannot do that. So what we need to do is put this one into what? Parentheses. So that when you want to multiply, then this 10 here will multiply everything here. So I'm going to have like 10 e to the power x plus 1 e to the power x plus x all to the power 9. Now you cannot also multiply this function by this and this. Like when you multiply this by everything here to get something like ex plus 10x to the power 9. No, you cannot do that because of the 9 here. You cannot multiply the 10 through. For you to multiply the 10 through, you need to expand this before you can multiply the 10. Yeah. So this is going to be the dy over what? The dx. Okay, I think I needed to show you something. Let's go back to this. Now with this one, let me just clean this one here. With this one, we can do the direct derivative to confirm if our result is true, right? So let's do the direct differentiation. When I finish, I'll go and continue from. So y prime will be equal to, as I said, this. If I have something like this and I want to differentiate, first we need to apply the power rule, right? So the power rule says that this drops down 1/2, right? Then I maintain the whole function, which is going to be x squared plus 7x plus 12, plus 2 to the power half, but I'm going to subtract 1. So that's the power rule. Drop down the half, maintain the whole function but subtract -1 times, so you will see what was happening here, times gen prime. Gen is the one in the parentheses, so times. Now we differentiate what is inside the parentheses, and we are going to have 2x plus 7. So when I simplify this, I'll have 1/2 x squared plus 7x plus 2 minus 1/2 2x plus 7. And we can see that it's the same as what we have here. So learn how to do it direct, like when you want to do it direct, right? And learn how to choose your f of x, gen of x, and also to arrive at this one. But learn how to do it direct, right? So this one that we did too, we can also differentiate it straight. So if I have this, then y prime will be equal to, first I apply the power rule. So the power rule says that the 10 drops down. So I drop the 10 down. I maintain the whole function, which is e to the power x plus x to the power 10, but I'm going to subtract 1, right? Times, then I take the derivative of what is inside the what? The parentheses. So when I differentiate e to the power x, as we saw here, we had it to be x, e to the power x, I think it's here, e to the power x plus, when I differentiate x, I'm going to have 1. So we can see that what we have here is the same as what we have here, right? So let me just simplify it. This is going to be 10 e to the power x plus x, 9 times e to the power x plus 1. And this is the same as what is here. So learning how to do choosing f of x, gen of x, learn how to also do the what? Learn how to also do the direct what? Differentiation. Like when I see it in a question, I can just look at it and what? Differentiate. Okay. So now let's look at the last one and then we go. So with this one too, the same process, f of x, gen of x, the same thing but different what? Functions. So as usual, we choose our gen of x to be the one in the parentheses. So this one is going to be x to the power 3 plus 5x squared plus 7, right? Then it means that this function now will be equal to, now the one in the parentheses here is now gen of x. So I'm going to have gen of x to the power 20, right? Then for me to write my f of x, I'm going to let this one to be u, so that gen of x is equal to u. I'll place the gen of x by u, so that I'm going to have u to the power 20. Then based on that, now I can differentiate this. Then I'm going to have 20u, 20 minus 1, which will be 20u19. Now I know that this u here is what is here, so I'm going to put it here. So I'm going to have 20 x to the power 3 plus 5x squared plus 7 to the power 19. I need to differentiate gen of x. Gen of x is this. So x cubed will be 3x squared. Then when I want to differentiate this, 5 is the constant here, so I just maintain the 5 and I differentiate x squared, I'm going to have 2x. When I differentiate 7, I'm going to have 0. So this will be 3x squared plus 10x. So for me to get this one, based on the change rule, I multiply this by this and then I'm done. So 20 x to the power 3, 5x squared plus 7 to the power 19 times x squared 3x squared plus 10x. So you see that anytime I want to multiply the function, I put them what into parentheses. So this is what we are going to get, and we can confirm by doing the direct what differentiation. So let's go. Y prime will be equal to, first we apply the power rule, so 20 will drop down, then I maintain, then I write the whole function x to the power 3 plus 5x squared plus 7, then 20 minus 1 times, now I differentiate what is inside the parentheses, which is going to give us 3x squared plus 10x, good, 10x, and when I simplify I'll have 20x to the power 3 plus 5x squared plus 7, 19, 3x squared plus 10x, which is the same as what we had here. So that is the general idea with the chain rule. Learn how to do the direct substitution, then you learn how to also do this process. But I think I can give you some tip bonus from what I was doing here. So what I was doing here actually was like me having y is equal to, let me say, gen of x to the power what, n. So you see that any function that we have, we can write it to the power n. So you can see that this is the n, and gen of x is what is here, right? The same thing to this one. This will be the gen of x, and this one will be n. This one will be n, this one will be gen of x. So if you have not watched the previous video, then if I want to differentiate this, then as we were saying that apply the power rule, n drops down, I maintain the whole function, n minus 1 times, then I differentiate what is inside the parentheses, which will be gen prime of x, right? Which we've gone through them already. So that is the idea of, if you want to go through the shortcut without using your f gen and then going through the whole of this. When you write it in the exponent form, then you go through this short process and then you are done. All right, so see you in the next video.